Welcome to this visual guide on IoT security, where I'll show you some essential security mechanisms that you can embed into your IoT solutions. Two essential resources you should use when developing a secure IoT service are the GSMA IoT Security Guidelines and Assessment Scheme, which were developed by security experts in the mobile industry and have been adopted by numerous mobile operators, service providers, governments and industry bodies. The guidelines cover all the common IoT attack scenarios and provide many recommendations on how to mitigate these attacks. The associated security assessment provides a comprehensive checklist to run through when you're testing your IoT solution to make sure it is secure. In this visual guide, I'm going to explain how the services provided by mobile networks can satisfy some of the key recommendations in the IoT security guidelines and other guidelines such as the ETSI Technical Specification 103645. The services that I'm going to demonstrate sit within the following key IoT security recommendations. No universal default passwords, securely store credentials and security sensitive data, communicate securely, minimize exposed attack surfaces. The services I'm going to demonstrate are generally network agnostic and relevant to all types of cellular connectivity based on 2G, 3G, 4G and now 5G networks. This of course includes the LTE-M and narrowband IoT low power wide area network technologies. I'm going to split this demonstration into two parts. In the first part, I'll explain how simple it can be to customize and lock down your IoT network connectivity, which is a really good way to reduce your IoT services' exposure to malicious fraud and security attacks. I'll give some examples of how easily this can be done in real time using an IoT Connectivity Management portal offered by two leading mobile operators, Bix and JT. This demonstration supports the recommendation in the GSMA IoT Security Guidelines to communicate securely, minimize exposed attack surfaces. In the second part, I'll explain how more and more mobile operators are offering IoT security services based on the SIM that enables the secure provisioning and establishment of end-to-end IP connections to the cloud. I'll show you a real example of one of these services being offered by a service provider called Twilio. The second part of the demonstration will support the following recommendations in the GSMA IoT Security Guidelines. No universal default passwords, securely store credentials and security sensitive data, communicate securely. Okay, that's the introduction, let's get started. Customizing and locking down your IoT connectivity. Let's look at how you can customize and lock down your IoT device's network connectivity. For any cellular connected IoT service, it is essential that you do this to reduce the attack surface that the cellular connectivity can provide. For example, some famous incidents have been reported in the past where cellular connected IoT devices have been hacked to dial premium rate phone calls, send premium rate text messages, or be used to create a botnet, all of which could be easily prevented using the services provided by mobile operators. There are also cases where IoT devices containing plastic pluggable SIMs are physically attacked to steal the SIM and use it for voice calls, text messaging and data connectivity. Again, this can be de-incentivized if you lock down the connectivity. In this example, I'm going to show how easy it is to customize and effectively lock down the cellular connectivity of an IoT device using a mobile operator's connectivity management portal. Most mobile operators who provide IoT services offer this capability to their customers. In many cases, a self-service interface is provided via a portal. For the purposes of this demonstration, I'm going to be using the customer portals offered by Bix and JT. To make it a bit more visual, I'm going to show how the network connectivity can be customized in near real time using an example IoT module provided by Seed, which is based on the u-blox IoT cellular module. So let me talk you through the setup. I have my laptop here, which I'll use to access the connectivity management portals provided by Bix and JT through my browser. And I have a Seed GSM Cat1 LTE modem here, which I will connect to my laptop using a USB cable. As the Seed modem is based on the u-blox module, I'll control the modem using the M-Center application, which is provided by u-blox as an evaluation tool for their cellular modems. You can download M-Center from the u-blox website. First, I will use Bix to demonstrate how to block voice and SMS services, lock a SIM to a device, and set a roaming profile. So let me insert a Bix IoT SIM into the modem and connect the modem to my computer. After a few seconds, the modem will register to my local network here in London, and I'll get a blue flashing light. And indeed it is, so it looks like we're connected. Here I'm going to open M-Center which is the software provided by u-blox. I'm going to click connect to connect to the modem. Click the initialization button. As you can see there, the modem's reported back its software and so forth. Then going to click on the networks tab and just check it's actually connected to a network. Click the refresh button. As you can see, it's reporting some network information here, so it's registered to the local network and it's ready to go. So that's the modem ready. I'll now open the Bix Connectivity Management portal and we can have a look around. Here I'm going to do a quick tour of the Bix portal. So let's open up the browser and log into the Bix Connectivity Management portal. So first thing I'm presented with is this dashboard. This just presents a summary of all the SIMs and connectivity that I have associated with this particular account. So you can see things like the volume of data that I've been using. You can see that as a total, you can see that per month, you can see the regions I've been using the data. So obviously the UK is highlighted here. And you can see all the different events that have happened on this account over the past few days. As is the case with most subscriptions, by default, many network services are enabled. So I can use pretty much any network service I like with this device. There's no voice service as this is an IoT account, but I can send and receive SMS, I can set up data connections, and I can send and receive data to anyone on the internet. I can also roam to pretty much any country and access these services. So let's see how we can customize the connectivity. First, let's look at SMS. So let's go into the portal here, go to the endpoint tab, select the SIM, the device that I have active in front of me. This takes us through to a specific screen which gives some information about this specific SIM and how it's being used. So again, some figures for the data being used, SMS being consumed, the tariff that's currently associated with this particular SIM. But you can see down here, we've actually got some barring options. And this is a very simple way of actually customizing the connectivity for this particular IoT device. So you can see some options here. I can potentially switch off 2G or 3G connectivity. I could switch off 4G connectivity. I could actually disable data. So if I had a device that's perhaps only using SMS to communicate, I could lock down the data connection. Inversely, if I have a device that's only ever going to use data connectivity, I could switch off the SMS capability so this device couldn't send or receive SMSs. So let's go and show how we can lock down the SMS. So I've just opened a window here. It's basically a mirror of my smartphone just showing my text message inbox. Then secondly, let's open the u-blox M-Center tool. M-Center provides quite a nice user interface for sending SMSs. Click on the little envelope symbol. I can send SMSs from the module I have in front of me. So I'm going to go ahead and do that now. So I put my phone number into the destination box, type a message, click send, and hopefully that message should be sent from my IoT module to my phone. And there it is. It's appeared on my phone. So that's all very easy, and as I said, there's no restriction currently on this this subscription, so that was allowed by the network. So let's now go and customize the connectivity. So again, in here got two options for SMS. I can switch off SMS mobile originated, SMS mobile terminated. In this case, I'm going to disable SMS mobile originated. Click yes here. So that's now configuring this subscription to bar SMS. So now I've got a message here confirming that's been done on the Bix network. So I now go back to the control center. I try and send another text message from the device. Click send. And nothing's happening. So here, in this case, the device is trying to send an SMS. The network is blocking it. It's blocking it from being sent. So it's not appearing on my my smartphone here. Sometimes it takes a while for the network or for the device to figure out the SMS is being blocked, but it's fairly clear here that it is being. Let's just try that again. So I'll just change the message, click send, and again nothing being received by my smartphone. So just to double check that it's working as intended, let's go back to the Bix console, and we'll just re-enable SMS mobile originated. Well, let's get that right. We'll just click yes here. So again, the subscription is now being updated to re-enable SMS. Go back to the console, change the message, click send. Hopefully it should now be received by my phone. Yep, so there it is. So SMS is now being enabled again. So it's quite a simple demonstration, but obviously, you know, if you have a cellular connected IoT device, it is pretty important you lock down the connectivity just to the services the device needs. You know, by disabling SMS here, I'm reducing the incentive for anybody to try and get hold of this device and use it to send spam SMSs or send premium rate SMSs. So it's quite a powerful feature to be able to switch this off on the network subscription, prevent all my devices from using this particular service. So next, let's look at how you can pair the SIM to the IoT device, so that if the SIM was removed from the device, it wouldn't work in another device. So again, looking at the Bix portal here, and clicking on endpoints, you can see in the endpoint details box here, we have an IMEI. Now, the Bix network automatically retrieves the IMEI of the device that you've inserted the SIM into. So this is the correct IMEI for the IoT device that I have in front of me. As you can see next to it, we have a little padlock icon, and if we click on that icon, then an association is made between this IMEI, device IMEI, and the SIM. So I'm going to go ahead and click on the icon, and obviously here I'm locking the device, locking the SIM to the correct device. So if I open mCenter and open the AT command interface that mCenter provides, I can just check the device is working properly. So firstly, let's just check the IMEI of the device, make sure it matches the IMEI on the Bix console, and of course here it does. Next, let's configure an APN and establish a PDP context. So in this case, the device is connected, it's got an IP address. If I start a ping, you can see you can ping away at Google. So I've got data connectivity for this device. So let's close down the PDP context, and we can go back to the Bix portal, and if we edit the IMEI, so in this case we're going to change the IMEI, so the IMEI doesn't match the device that I have in front of me, and apply that different locking, and we now go back to mCenter. We can check and find out what's happened and whether that device locking is having any effect. So again, we can open the AT command. In this case, again, we're going to try and re-establish that PDP context. And in this case, as you can see here, we're getting an error back from the network. So the network is recognized that this SIM is in the wrong device and is not allowing us to establish a PDP context. So just try that again. Again, I get an error. I try and ping Google, I get a error message coming back because there's no data connectivity being offered to this particular device. Let's go back to the console and do the reverse. So in this case, I'll just edit the IMEI again, make it correct, apply that to the subscription. So now we have the correct pairing on the portal. We can try and establish that PDP context again, and as you can see here, it's now working. I've got an IP address, I can ping Google, and there we are, the ping is successful. I'm getting a response back. So there, you can easily see how easy it is to set an association between a device IMEI and the SIM. This is really useful because obviously if the SIM was somehow extracted from this IoT device and put into a different device with a different identifier, then the SIM wouldn't offer any data connectivity or indeed any services to the other device. So it really de-incentivizes anybody to try and prize the IMEI and prize the SIM out of your IoT devices. So let's look at another service offered by the Bix portal, and that's how to set a custom roaming profile. Now IoT devices, or most IoT devices, they're static, they stay in one place, and therefore it's sensible to lock down the connectivity so that the device can only connect in the particular region that it's located or country it's located. And you can do that by setting a custom roaming profile on your subscription. So from the Bix dashboard, we click on the coverage tab, and a map will now load on the screen here, and it'll show the default roaming profile. So here's the default profile loading. 316 networks associated with it. Now it's rare that an IoT device will need to sort of roam globally like that. Typically they're fixed to a particular location. So it makes sense to set a custom roaming profile, and do that by pressing the Add Roaming Profile button and selecting from the operators listed below. Here I've actually set up a couple of profiles already. So this first profile is limited to France and Italy. So here I've basically just selected the French and Italian networks, added them to the list. So a device using this profile will only ever be able to connect in France or Italy. And similarly, I've got a UK roaming profile set up here just with the mainland UK networks. And again, if I applied this profile to my subscription, my device would only be able to connect in this location. Okay, so let's look at another connectivity management portal. In this case, the one provided by JT. Let me just put a JT SIM into my device here, and we can get started. Using the JT portal, I will demonstrate how to set data limits and set alerts, and an example of IP address whitelisting. Okay, so I've just inserted the JT SIM. Just need to check that it's connected to the network here in London. So let's open mCenter. Click Connect to connect to the modem. Click Initialization. You can see there it's read the information from the u-blox modem. Let's go into the Networks tab, click Refresh Info. As you can see there, it's registered to one of the local networks here in London. So we're all set and ready to go. I will now open the JT Connectivity Management portal, and we can have a look around. Here I'm presented with a sort of main dashboard. This is for my whole account that I have set up with JT. Here I just get an overview of the amount of data that I've been consuming on this account. In this case, I've not really been consuming much data, just been using one SIM. I've just been using it to prepare these demos, so not too much data being used. Get the map here showing where the data is being consumed, so in the UK in this case. And at the bottom of the screen here, I've got some list of warnings, and I'm going to talk a little bit more about those warnings later on in the video. A really useful service offered by these portals is the ability to monitor the activity of your SIMs. You can set alerts when data thresholds have been exceeded, and you can also automatically suspend devices. I'm going to show how you set a Watchdog timer, so to set a data threshold limit and to get an alert sent once that threshold's been exceeded. So click on the SIMs tab here on the JT console. Select the SIM that I have in the device in front of me. If I scroll down to Watchdog and click on this little tab here, I can add a Watchdog. What I'm going to do here is actually get the system to suspend this particular SIM when a certain data threshold has been exceeded. So the action type I'm going to select is suspend. Watch type is external service group. By selecting that option, because I'm currently roaming, not on the home JT network, I'm on a roaming network, it's going to give me a far more reactive time when the thresholds has been exceeded. If we then select an interval, let's set a 1 day interval, 1 day suspend. I'm going to choose 3 megabytes of data so that we can do this demo pretty quickly. I'm going to set service zone 1 because I'm roaming in zone 1. Set it to megabytes. I'm also going to get the system to send me an email when the threshold has been met. So I've set myself up a little test email account here. I'll just enter the email address for that here. And also I can set some interim warning thresholds. So just do that, click next, finish, and that's adding the Watchdog to the system, and that looks like that's been successfully applied. I've got my phone mirrored in the top corner here showing my email inbox. So hopefully some warning should appear there once the demo is underway. Okay, so let's open M Center again, connect to the modem, do an initialization, click the network tab, just check that the network is connected. It is. Open the AT command interface. We'll configure the JT APN, set up a PDB context. So there we are, we've got an IP address. Let's do a ping, just check that we've got connectivity. We have, so that ping is successful. Now I'm going to actually do an HTTP GET to get a large file down from the network. I'm going to use a service provided by Tele2. They've got a HTTP server somewhere in the world with some files on it, and I can get those files by doing an HTTP GET. So let's do that now. In this case, I've just issued an HTTP GET to download a 10 megabyte file. If I click again on MCenter, the file system tab, you can now see that file downloading. I click again, you'll see the 196 kilobytes so far. It's been downloaded. Obviously, it'll take a little while to do the full 3 megabytes. Reason that we want to set these thresholds is that IoT devices typically use a pretty well-defined amount of data. You know, if you've got an IoT device periodically reporting back to a server, you probably know pretty accurately how much data that device is going to send in a particular day or particular week. So it's advisable, therefore, to set a threshold so that if the device starts sending more data than expected, you get an alert, or indeed you perhaps could even suspend the account whilst you do your investigation and find out why the device is suddenly consuming more data than you expected it to. Okay, 2.8 meg, so very close now to the threshold being met. In fact, there we are. So we've actually now just got an error message back on the HTTP GET to say that the GET's failed. You can see my email inbox there. I've actually got a Watchdog warning appear in the inbox to show me that something is going wrong here, that some sort of issue is happening. Let's perhaps just open up my email so we can see what the content of that email is here. Okay, so as you can see here, so we've got an email here, says the SIM has reached 3 megabytes of your allowance of 3 megabytes. So clearly that threshold has been exceeded. If I got this email in real life, I know that that device is misbehaving, and I could launch an investigation and find out what's happened. You know, has some malware affected that device? What's going on here with this particular device? If I go back to the console, refresh the console, you can see that that SIM is now in a suspended mode. So that device, that SIM's completely suspended. I can't do anything with it. I can't send data. I can't do anything with this particular SIM till I click the resume button on the console here. Okay, so for the next demo, I'm going to show how a mobile operator can lock down the connectivity to a specific IP address or set of IP addresses. In this case, JT have set up a private APN for me called Test3, which has an IP address whitelisting function. This means that if I configure my SIM to use this APN, my IoT device will only be able to send and receive data from the whitelisted IP addresses. This is a really powerful way to prevent a hacker from attacking your devices, as they won't be visible to the public internet. Also, if your device is somehow compromised, the connectivity available to the attacker will be very limited. So let's show this in action. So I'm just going to open MCenter, get the AT command interface open here. I'm also going to open a couple of Linux virtual machines running on AWS. So both of these virtual machines actually have an static IP address associated with each one. Just going to run a command on these each box to monitor the UDP traffic coming in on port 7, so on both of those virtual machines. So any data should appear on the screen for each box. Let's go back to the AT command interface. So firstly, in fact, if I've got a PDB context already active, so let me just quickly deactivate the PDB context. And we'll set the APN to the general purpose JT M2M APN. So this is a completely open APN. All services are enabled using this APN. So let's set the PDB context up. I've got an IP address here. Let's do a ping to Google. And as you can see, there we are. Google is responding back to that ping. Let's open a UDP socket and let's try sending some data to each of the two Linux servers here. So there we are. You can see I've just sent some data to server 1 using the IP address of server 1, and likewise sending some data to server 2. Okay, so let's close down that UDP socket and close down the PDB context. I'm now going to switch to the private APN called test3, and this APN only allows access to certain IP addresses. So I should see some different behavior here. So firstly, let's open the PDB context and let's try and now ping Google and see what happens. So the ping's been sent, and as you can see, I'm getting an error back this time. So the packets aren't coming back from the Google server there. The IP address of that Google server isn't on my whitelist, so I cannot therefore communicate to it. Let's now try sending some data to those Linux virtual machines. The server 1 here is on the whitelist. The IP address of server 1 is on the whitelist, but the IP address of server 2 isn't. So let's first try and send some data to server 1. So just establish the UDP socket, send some data, and as you can see there, the data is being received by server 1, so that's on the whitelist. Let's do that a few times. Let's try the same for server 2. So try and send some data to server 2. As you can see, nothing is coming through on server 2. So server 2 IP address is not on my whitelist, therefore I can't communicate to server 2. Let's just close down that UDP socket, close down the APN, and let's go back to the general purpose APN once more, set up the PDB context again, and now I should be able to send data to both servers. So there we are, data being sent to server 1 and data now being successfully sent to server 2. Okay, so let's just close that down again. Obviously, the advantage here is that if you set this IP address whitelisting, again, for most IoT services, you're only ever going to send data to one or a few IP addresses. There's no need for these devices to ever send data to any other IP addresses, open IP addresses. So, block them off. If somebody then does compromise your device, this device is pretty useless to them. They can only ever send data to your servers. They couldn't use these devices to set up a botnet or do some sort of malicious type activities. Again, really just de-incentivizes the attacker to ever really look at your devices and ever try and compromise your IoT devices. I hope you've enjoyed these demonstrations. I've only really scratched the surface of the features that these connectivity management platforms offer. There are many more features that can be provided by your network operator beyond these simple capabilities to customize and secure your IoT device connectivity.